Welcome everybody. So my name is Cedric, the VP Product Management at Canonical. So we have a full day of the Operator Day. This is the sixth time that we have host Operator Day. The common theme that we have seen during the day is that Kubernetes really took off as a de facto runtime for cloud-native applications. But we still experience a lot of expectations in terms of tooling to simplify the usage of Kubernetes. As usual, we regularly collect and share data prior to the Operator Day with our survey, which is Kubernetes and Cloud Native Operations Survey. And we will share probably the results during the panel discussion when relevant. In this panel, we will review the landscape of the software operators. We recognize a subject matter expert here in the cloud native domains. So I'm very honored to have this panel with first Mark, the CEO of Canonical, and many seasoned experts in the Kubernetes domain. So let's do a short roundtable to discover our panelists today. Mark, do you want to start?
Hello, everybody. Mark Shuttleworth. I run Canonical. I have a fascination with Kubernetes and a fascination with how open source is moving to distributed systems and how to kind of make that easy for people in the same way that once upon a time Ubuntu was all about making that first step into open source easy. But I won't pretend to be too much of an expert, and I'm looking forward to learning from some of the other panelists about how the stuff actually works or should work.
Okay, thank you very much. Lachlan?
Hello, everybody. I'm Lachlan Evenson. I'm a product manager over at the Microsoft team, and I focus on cloud-native upstream ecosystem projects. I've been working in the Kubernetes and cloud-native ecosystem for many years. Witnessed the birth of the operator pattern, so very excited to be here today to discuss operators with you all, and great to see you.
Thank you, Tim.
Hi, everyone. I'm Tim Hockin. I've been working on Kubernetes since the beginning. I have somehow found myself co-leading SIG network. I pay attention to SIG multi-cluster and node and API machinery in my copious free time. And I work at Google, but I'm really focused primarily on upstream Kubernetes and the evolution of that.
Thank you, John.
Hey, so I am VP Engineering of Enterprise Solutions at Canonical. I've been there for about 2 years, which means that I lead the development of Juju, our build tooling like Snapcraft and Charmcraft, but also a whole host of charmed operator teams who are looking at building first-class operators for kind of a bunch of different types of software, whether that's databases or observability tools or machine learning tools. I'm kind of looking forward to getting a bit of outside perspective this afternoon, and also perhaps learning how Tim Hockin has copious free time, which is something I've not achieved recently. But yeah.
Thank you, John. Thank you, everybody. So during this panel, I will call you to answer some questions just to drive the discussion, but sure, feel free to ask questions and to respond to any comment of others. Maybe I would like to start with Mark, because Mark, today we see a lot of cutting-edge technologies, demonstration of how the software operators can really simplify the management of the lifecycle of application, such as MySQL, WordPress, Kubeflow, automating the deployment of Kubernetes clusters. Today, software operators are very popular, and according to the survey that I mentioned at the beginning, 60% of the Kubernetes engineers are really familiar with them, and more than 20% of them are really using them in deployment application for production. So what were the main progress and success of the operator pattern so far?
Well, I mean, from my perspective, I think the promise of software has always been to remove toil. And we're seeing that same idea expressed now in the operations domain for essentially software driving Kubernetes operations. To my mind, that has long been a kind of like a useful idea. I think there is a school of thought in the Kubernetes world that says, look, the good thing about Kubernetes is it does only what you tell it to do and nothing else, so that there are no surprises when you're not looking. But the flip side is, I think that requires too many people to know too much about too many things. And my hope is that it is through operators that will effectively deliver a better user experience for stuff that should just work, and share the burden of of making it so. In the same way that we do in open source itself, and then in distributions like Debian and Ubuntu and many others. There's large amounts of code that is handling important stuff that, in a sense, you could argue an expert might need to know everything about everything, but we managed to get by without everybody know everything about how all of that stuff works. Maybe we should do the same on top of Kubernetes. So I'm excited about that and a believer in that. My view of where we're at right now, more and more people are interested in this approach. I think that showed up in the survey. And more people are looking to create this class of code, software that drives other software on Kubernetes. As is normal, there's a kind of a Cambrian explosion of approaches and so on. And my interest is in the kind of grand unifying operations theory. We express that in Juju, in essentially saying, look, if you have a single unified model, it doesn't much matter who wrote what operator or what language they wrote it in, or those are sort of details. Can we essentially give people a user experience across all of the operators? And so that's the great big charming adventure that John leads at Canonical. I'm very interested to hear about things like the state of the art of observability, essentially discovery, integration, all of these things that essentially enable people to use software that's been written. I'm hoping we'll touch on some of that today.
Great. And Lachlan, I would like to ask you, can we say that now the cloud native ecosystem is easier to use thanks to operators, or at least to some industries, and in some industries and others? What is your view about that?
Yeah, I think I don't know that I'd say it's easy to use. I think we're on the way with operators, and we can chart a course using the operator pattern to do that. I think there are specific workloads that have had really good high value success using the operator pattern. I think databases, eventing are some areas that have been more successful on there. And, going back to Kubernetes being a platform to build platforms, I think one of the things that the Kubernetes ecosystem got right really early was setting a model through custom resource definitions to be able to build operators on top and extend the Kubernetes API. And as Mark was saying, take all these bespoke scripts that are shoved everywhere and kind of unify them into a central place and use a single control plane. But I think, the journey is only half done. I think discoverability of operators is still really hard to find an operator that suits your needs. I think we haven't really delivered well on the promise of the day two operation. So operators are still really good at laying down some infrastructure or running up a set of databases. But let's say if you want to run a Postgres cluster or a MySQL cluster on a Kubernetes cluster, day two operation still, I think, leaves a little to be desired. Say you want to snapshot, back up, grow, shard up a cluster, or do something really interesting and challenging like that, as you would want to do as a database grows over time. I still think day two operations are a little challenging. And I know that there are maturity models for operators out there where somebody can discover and then look at the maturity of what they implement. But there's really different UXs across all operators. So I think there's still a lot of work to be done to create some unified experiences. And what I've seen with our customers is really using operators together. So using them in a vacuum is kind of great, but you want them to be greater than the sum of the parts. So you want a whole ecosystem of platform tooling built on operators that can essentially even work with one another. But I think a lot of the operator patterns that are being developed today, here's your databases, here's your observability stack, here's your next stack, but they don't know how to collaborate or communicate with one another. So I think there's still a lot of work to be done. But the great news is, I think as we mature in this ecosystem and more languages and open source comes online to demonstrate that operator pattern value, I think that we're only going to get better results out of the operators and better maturity.
Great, thank you very much. Tim, as a principal software engineer at Google Cloud, right, I'm working on Kubernetes, I believe, since the beginning, and with Hybrid Cloud as well. What do you see in terms of current trends about Kubernetes regarding the operator technologies? What are the challenges that are addressed today, and how can we, accelerate the transformations to the cloud native landscape?
Yeah. So I see. I get some echo. So I'm seeing a couple of different challenges here. One that I'm paying attention to a lot right now is the ease of writing an operator. I think Kubernetes makes us jump through a few too many hoops to write a correct operator as an API surface. Kubernetes, as an API extension system, has all the right pieces, but they're not always the easiest pieces. And so there's been a lot of work this year in making that easier, making the simple things easier and leaving the hard things still being possible. So I'm really excited about that because I think that lowers the bar for experts who, maybe know one of these systems very well, but don't want to also have to become experts in Kubernetes to try to bridge the gap. I think it'll make that easier for them to use. The other thing that I've been paying a lot of attention to is that sort of cross-cluster, multi-cluster, large-scale sort of problem where, people are using Kubernetes sort of as their own control planes. And it doesn't always match the semantics that they want out of a control plane or the scale that they want out of a control plane, or maybe the IOPS that they want as a control plane. And so finding better patterns and better ways for people to build an operator in a way that feels natural for the sort of thing that they're describing in their operator, without them having to sort of adopt weird positions just to appease Kubernetes.
Thank you, Tim. I want John to react to this. And he is an expert in many development technologies. And John, you have to use many different technologies, right? From Terraform, Juju operators. How you will compare all those technologies, how they can complement each other to address the challenges that Tim mentioned.
Yeah, so I think to some extent I resonate quite a lot with what Lachlan was saying, and that we've become very good at deploying code, laying down infrastructure. And so to a limited extent with things like Terraform and Ansible, there's not a lot you can't provision at day zero, day one, right? They are both kind of Swiss Army knife style tools that allow you to get right down into the nitty gritty details of each platform that you're on and kind of get exactly what you want. But often the ongoing operations of the things you've laid down ends up being a whole pile of Cedric and greppery and bash scripting and CI jobs on cron and these kind of things. And interestingly, kind of as a broader trend in open source, it seems like the industry has become very good at open sourcing applications sort of by default, but there's been almost a shying away from open sourcing the operations code, right? And so a lot of this stuff is kind of behind closed doors. You hear about big names like Google, Spotify, who have apparently got these amazing engineering outfits where they're managing to somehow wrangle all of this stuff in production on an ongoing basis at enormous scale. But while they're busily open sourcing products, they're not necessarily open sourcing how they are going about achieving that. And I think one of the reasons is that ultimately it changes super quick. So one of Kubernetes' strengths, I think, is in how quickly it's managed to evolve and change. And it has this very well-defined kind of support lifecycle for when things are coming in and out. But because that API changes quite frequently, I think we end up in a situation where the various frameworks for writing operators also change quite frequently. And so you end up with this kind of fragmented, a pattern that was designed to solve the user experience problem for operating infrastructure ends up fragmenting its user experience because all of the different operator frameworks, if you will, have different ways of interacting. I think for me that one of the core, or really the core aim of Juju is not deploy infrastructure. That's kind of a solved problem. I think if we stopped there, we'd be a little silly in some respects. I think the core thing I'm focusing on is, okay, you've deployed these things, how do you make them speak to each other and how do you operate them? The day two kind of operations actions thing, right? Which is something that's been baked into Juju for a very long time. And one of the things, there's a long way for us to go with Juju, I think, before it takes over the world. But one of the things that I think it has done very well is provided a very, very stable API as to what can be called inside a unit, inside a pod, inside a VM, and because it is kind of cross-cloud. And those set of primitives that we present in terms of providing status, maintaining state, communicating with other parts of the infrastructure have stayed very, very stable, which, is powerful, but has also presented us some challenges at times with keeping up with the pace of change of, the various substrates we support, Kubernetes being probably the most obvious example of that. So I think operators are making it easier to work with platforms like Kubernetes, but I think much as kind of the Linux ecosystem kind of dispersed a little in terms of things like package management, the age-old debate there, a similar thing has happened with the operator kind of ecosystem, and it still feels like there's kind of a reconciliation that's going to have to happen at some point. Having 15 different frameworks writing operators isn't going to serve users any better than just having 15 different tools for laying out infrastructure, I don't think. And so I think that's going to be interesting to watch over the next couple of years for sure.
Thank you, Tim or Lachlan. Do you want to react to this or no? I think there is something in my mind, that was a bit disturbing in a sense that Helm was considered as one tool, the most popular tool for application deployment in Kubernetes. But according to our survey, and we are experienced in Kubernetes and using Helm, it's becoming quite complex if you have multiple charts and you have more than hundreds of charts to deal with, right? So the usage of operators are really providing a kind of solution for that. And in this aspect, we are speaking here about scripting instead of imperative in terms of declarative. And what we see is that there are a lot of innovations in terms of scripting languages, such as Starlac or Wasm or the Hive, which is the script for Rust. Do you see that these technologies are actually a way to democratize the usage of operators, and maybe replacing in the future more declarative approach such as Helm? Or do you see the two working together? Tim or Lachlan, you want to react to that?
I can start. So I'm getting an echo again from somebody. Sorry. Helm is an interesting problem because it, I think, captures sort of in a microcosm the entire space of the problem. As an API, APIs are complicated, right? Kubernetes has a lot of API surface, and it's mostly there for reasons. I say mostly. As things evolve, as a Helm chart evolves, the entire Kubernetes service becomes the Helm surface, right? And so you sort of transliterate from one API to another API in the extreme, and you don't lose any complexity there, right? You don't get to hide anything. Eventually, the abstraction leaks, unless you're willing to be super opinionated and say, I'm not going to take these extra inputs. I'm not going to let you twiddle that one particular knob. And what I've seen is that the willingness to hold that line is pretty low, right? Within an organization, somebody comes to you and says, I really need to twiddle that knob because good reasons, my business. And you say, okay, fine, I'll add it as a parameter. And now it's part of your API service. And this isn't a charge against Helm. It's a charge against trying to wrap an API with another API without taking some form of opinion or position statement on what your API is for. And in the limit, all templating systems are terrible. And Helm at its bottom is a templating system, right? And I wish I knew what the answer was. I wish I knew what the magic wave a wand and get a perfect system here is. I see operators as a way to take those opinions and to say, well, this is the way you do it. And we're not going to let you twiddle those low level knobs because we own those knobs. We are controlling them. Our operators' virtual hands are on that knob, so you don't get to touch it. And you can build that smaller surface area but higher value to the customer by building it into operators. As for declarative versus imperative, I'm a big fan of declarative, although sometimes it really forces you to bend your words to say things in a declarative way. Take a snapshot now becomes ensure that a snapshot with a timestamp of at least now has happened, right? So there's work to be done sort of in how to model imperative action still, I think.
Right, very nice. So actually, it's interesting because we see the success of some opinionated version of Kubernetes, I would say, lightweight or very focused. So for instance, micro-K8s, and according to our survey, 27% of the respondents are using micro-K8s, but like Minikube or K3s, for instance. So what is the main use of those opinionated package version of Kubernetes? Maybe Mark, you want to jump on it?
I tell you what, I'm intrigued that other container orchestration systems, which set out to be kind of opinionated, haven't taken off. At least my observation is that they haven't taken off. Maybe I'm missing the new thing. But, there are a couple of folks who said, hey, containers are fairly standard. Why don't, and Kubernetes is like big. And Kubernetes lets you do it has all the knobs, but maybe you don't need all the knobs. Why don't we build a simpler, cleaner container operating environment in order to just give people a nice kind of opinionated view? And to the best of my knowledge, none of those things has taken off, right? There was Docker Compose and so on, and it's not like that's coming back as best I can tell. Nomad is another thing that comes to mind. So I just kind of say that because as much as people I think do like the idea of something that's a bit more opinionated, a bit more on rails, a bit more directed, I don't see appetite for leaving Kubernetes behind with all of its complexity in favor of that. It seems more about a discussion within the Kubernetes space about, well, how to find simplicity in that space. My own feeling is that most people should just push the button on the cloud, right? Like, actually, the clouds work very hard to give you a good Kubernetes that celebrates what the cloud does very well. That's probably the right Kubernetes for most people to use. I think that the more interesting questions have to do, with how you might choose to limit your behaviors on top of that Kubernetes and why you would do that, right? The fewer knobs, fewer buttons, fewer options question, I think is not so much interesting as like an alternative to Kubernetes or particular brands of Kubernetes. It's more about how you would limit your application management behaviors on top of Kubernetes. I don't really have any good answers there. I recognize very strongly what Tim said about the but I must have type thing. My gut feel is that somehow we have to turn this into carrot, not stick. That there's something that's so attractive that people are willing to come to a place that's simpler rather than being told they're not allowed to have the complexity. There's a bit of a ramble for you.
Cedric, you're mute.
Oh, Cedric, we've lost audio from you.
Sorry. Yeah, I wanted I would like to hear Lachlan about this. I mean, what would be your advice for the cloud native developers?
Yeah, and I think, at this time, it's if we look back for the last 8, 9, 10 years, it's almost 10 years now, right, Tim, that the first line of Kubernetes code was written. It's, if you're walking into the Kubernetes ecosystem today, you don't need to be bridled or burdened with 10 years of history just to get your first workload out the door. And really, I often think about that as I've been in that journey, but now imagine if I'm just walking in today and how am I going to react and what do I have to know? And I've been able to step and know each API as it's been introduced and add that to my portfolio in my mental model of how Kubernetes operates. But I can't expect everybody who's walking through the door today to have 10 years of history before they can be effective on Kubernetes. And I think that's, how do we start to do that? And it's, like pulling on some threads that Tim and Mark have brought up, we have such a kind of appetite for, I need to do something bespoke, I'm special, and there's something that there's a knob that I must touch, that we end up always looking for the Swiss Army knife. And we feel really burdened by anything that's less than that, even if we don't need it. So we're always looking for that break glass moment and say, hey, how do I get back to the Kubernetes API? It's all great that I have this really great little PaaS that somebody's built on Kubernetes, but is it Kubernetes under the hood? Because I may need that. And just really, I don't think that the next 10 years of cloud native developers are actually going to care as much about Kubernetes. And what are the things that we're going to provide without them necessarily caring about, you mentioned Helm, a bunch of YAML. Do they need to understand how the all the networking and the storage stack and the way that services are tied together. Can we create some experiences that make that much easier? And I really think that we need to work hard on gluing those things together. So I think that's what I'd say is, don't get stuck in defining your value as a developer of how many resources or how many Kubernetes APIs you know. It's really about how effective you can be without knowing all the APIs. That'd be the measure that I'd like to put in place. So, I often see it goes around once every year, somebody kicks up, look how many lines of code this, looks at how much templates in this, YAML Helm chart. And, it's like, the fact that you know that is probably not ideal, but it may be happening under the hood. It's where do you want to stuff that thing? And do you need to know about it? I always say, my declarative is your imperative, or the other way around. What you say is declarative and how I define that, meeting that needs, as Tim said, it's kind of like you have to sometimes stretch the words. But I think what is a really interesting pattern that's coming from operators is really the ability to create an API on all your bespoke scripts and package them up in a way that you can move them throughout time, so they're not just sitting in somebody's home directory under a desk. Now they're suddenly running live in a system. There, you have some source code repository around it, and you have proper development practices. So gone are the days, when I was working on these platforms, a much younger version of me had all these bespoke scripts that I'd, written in all these different languages that I wanted to procure over time. That now doesn't really matter as much. It's how do we build a system and move those scripts through this online declarative approach. And I think that's a much more powerful operating pattern for the folks out there who are with the pages. As John said, it's often that, you give the application away, but the operation's on you and you get to go figure that out. And that's your journey. And maybe you'll write a blog about it if you're successful. But really, how do we hand over the operational best practices in these things as well, I think is a really interesting quandary for the community, because we omit them, honestly, more often than not.
John, do you want to react to them? How Juju can help, for instance?
I'll definitely get to that. I was sort of trying not to jump in over the last 5 minutes. I think on the kind of must-have knobs and dials and buttons, I think, and kind of advice to developers, I guess it increasingly appears to me to be like who is your audience, right? I have a bunch of teams building a bunch of operators for things like high availability Postgres and Kubeflow, like big, complex distributed systems in their own right, built on top of our big, complex distributed system, right? And I guess the point is our target audience the world's most foremost expert on Postgres operations? No. Like, that person probably does want all the knobs and dials, but the poor guy or girl in the platform engineering team at X company who's been told, I want this web service that happens to be deployed on, in need of Postgres. Can you run this thing for me? They don't want all the knobs and dials from Postgres. They want to not get paged out of bed at 3 a.m. when their Postgres has fallen over, right? And I think that's from my perspective, that's the problem we're solving for. And like, it's the 85, 90% of people who want a Postgres. They want to be able to scale it as big as it needs to go, operate it for as long as they need to operate it, and say to the people they're operating it for, you're not going to lose any data, and it's going to be up for this many, or it's not going to be up for this many seconds or minutes or hours in a year. And I think it really comes down to, if you are the developer building these things, like, who are you developing for, right? Helm is a classic example. Like, it does solve a problem. Some of the smaller Helm charts feel kind of elegant. They're small, they're, useful in their own right. But some of the larger ones is kind of like sudo curl to bash for the cloud, right? It's like, what the hell am I spewing into my cluster? Like, there's tens of thousands of lines of templated YAML. Like, what is it going to do? Like, how many people can hand on their heart with a completely straight face say, yeah, I've reviewed every line of that, it looks good to me, right? Like, not very many. I think where Juju can help, and this comes back a little bit to the kind of imperative versus declarative conversation, where I think there is like an inherent tension there. Like, declarative stuff is very elegant in some ways. It enables you to do things like GitOps, for example, where you're kind of just doing state reconciliation against, like, what does the world look like now? What do I want it to look like? But there are places where it's not so great. And you see this very, very clearly in tools which I very much admire. So For example, HashiCorp's Terraform, which I became intimately familiar with, probably to a greater extent than I would have liked a couple of years ago. I have a great amount of admiration for what they did. And I thought HCL in the early days was quite elegant, quite clean. It was easy to write, it was expressive. But as as they started to grapple with the problems that customers were coming back with in real life, like operating big, complex systems, they're like, we need to get loops into this declarative thing. And honestly, the outcome is not super intuitive, right? Like as a developer, I look at it and go, that's probably not how I'd have wanted to write a loop, right? But they're kind of stuck because it is inherently a declarative system. So I think these scripting languages like Starlark, like Rye, etc., provide a sort of escape hatch from those places where you can absolutely achieve a lot of what you want to do with declarative configuration, but at the point where you need something imperative, you kind of need something imperative, right? And so providing developers who need to write those things with what feel like first-class tools and where they can interact with the system in ways they are comfortable. And I guess the important bit is like, how do you integrate that tastefully, right? Like know when the imperative thing's going to be, called, what its side effects are going to be, how does that affect the rest of the declarative configuration? That's the really hard part, right? And it's a problem that we are right now grappling with in Juju, in terms of you can declaratively essentially say, put these charms down in this model. We even have a Terraform provider that allows you to say in Terraform, here's some charms I want you to deploy on OpenStack or on Azure or on K8s. But there are elements about, like, especially when scaling and, well, more so when scaling down almost, big complex distributed things, you kind of need to say like, okay, well, I need to tell that unit to wait a second. I need to scale that thing down there. And then there's an ordering, right? Which might be ingrained in the head of the person who knows the system inherently, but you've got to be able to express that somehow. And declarative tools really struggle there. Our current thinking is to use something like Starlark in that situation and kind of provide a place in the life cycle to allow those interventions with a tool that is designed for those interventions, right? So hopefully that answers your question, Cedric. That kind of
Yeah, definitely. I was looking and I saw that Tim was nodding. Indeed, maybe Tim, you want to add something?
The pendulum between declarative and imperative continues to swing. We've recoiled against imperative systems and moved to declarative, and you saw Hashi, and the same sort of experience, right? Like, we would never, knock on wood, never embed a loop into a Kubernetes YAML. There are schemas that describe loops in YAML, and I would fight really, really hard against ever adding that sort of thing to Kubernetes. But as you described, there are events in a life cycle, in a state machine of a system, that you need to tap into those sort of events and those moments. And declarative systems are not great at that. And so we'll see the pendulum swing back towards imperative stuff. And then people will eventually get tired of the fact that they can't reason about, tool around imperative systems because it's code, it's Turing complete. And how do I make an automated change to the entire code base if everything is being generated by random bits of code that I can't think about? And we'll continue to swing back and forth. I hope that we're slowing and zeroing in on, a balance. But actually, I haven't really seen any evidence that that's true. I wanted to also touch on one other point that came up, I think, while Lachlan was speaking. The idea of all the knobs that we have and all the things that get exposed through Helm. Kubernetes has taken a pretty strong position of not getting rid of APIs and not breaking APIs. And it took us a little while to really settle on that paradigm, but I think we've embraced it pretty hard right now. And the downside of that is we don't ever get to get rid of anything. And so for every knob that has a value of X, Y, and Z, there will eventually be values of A, B, and C because we can't get rid of the old ones. And so, there's somebody somewhere who's using every combination of every knob that we have, and we refuse to break those things. And as they bubble up into higher level systems, as they show up in your Helm template with a bunch of different options, it just boils that complexity all the way up to whatever surface the end user is touching. And I guess if I have words of encouragement for our community writ large, it's let's try to stop doing that. Let's agree on what the right values are for some of these evolved knobs where the values are there for historical reasons, but not for practical reasons.
I always really admired Linus's, absolute clarity on the, on not breaking expectations in user space. If you put something in place, even if you now think it was a bad idea, you're going to live with it. And he, famously rubbed people up the wrong way sometimes. But I think the spirit of it, the underlying insights, is just brilliant, right? That you and it's underpinned a tremendous amount of the fluidity of the Linux ecosystem, right? The fact that you can get stuff to just work. Even there, though, I think there is an established pattern of ultimate deprecation. I don't know how Kubernetes would go about codifying a view of that. I think what Linus does is say that you're not going to do this lightly. You're not going to do this, just because you had a change of heart as a maintainer. But you can do it at the scale of generations of major version. Is there a similar view in Kubernetes now that these things can evolve? It's just it's not flapping. It's more deliberate than that.
We wrote the rules around deprecation on the assumption that we would eventually need an out here, a way to be able to get rid of things. And we wrote it at the granularity of whole API versions. So like core v1, right? Anybody who's written Kubernetes YAML knows core v1. We'd have to get rid of all of core v1. And we set the bar really, really high for how long it takes to get rid of an API version. And then over the last 2 or 3 years, as people have gone through transitions through betas, we've learned a lot about not leaving things in permanent beta. And the pain that we all collectively, in the cloud operators in particular, have experienced with our customers who are laggards. They're just not interested in this. It's not their problem. And we have to go and beat them around the head to get off of beta APIs. And we said, but it's beta. You shouldn't have been relying on this anyway. I said, yeah, but you left it in beta for 3 years. So what else were we going to do? What we've taken away from that lesson is the bar for taking away an API is so high, I can't even describe it. And so right now there is no plan in Kubernetes to get rid of, for example, core v1. All the mistakes we made in core v1, all the fields that are soft deprecated, they still exist, they still work, but we would wish they weren't there. There are better ways to do things. Those will exist in perpetuity until we have a good enough reason to get rid of core v1. And even then, it will take us literal years as we transition people off of that and into the newer stuff. And I think, like Linus's sort of doctrine of we don't break user space, it's really important because the customers who use Kubernetes, the world that runs on Kubernetes, doesn't care about our internal evolution. This is our problem, not theirs, and we should not outsource it.
I think that was kind of an interesting point you said about the people who use Kubernetes. And Mark, it goes back to something you said earlier on. I think one of the interesting things about Kubernetes is the complete, and like by comparison to almost anything else at its scale and its complexity, the complete and utter fascination of people using it who probably don't need that much complex, right? Like I would argue the Docker Compose probably hasn't gone away. Like there's a place for it, right? Like if you want to stand up a thing on your laptop or you want to run some Plex or whatever it is you want to run at home, you're probably going to have a quieter life if you just run that on Docker Compose. But it's interesting, I think, partially probably because people look at the Googles, the Metas, whatever, and go, wow, well, it's good enough for them. It's probably good enough for me. But it's more, I think the question should be, it's good enough for them. Is it the right, like, I'm not them, right? Like, it's kind of interesting how those other platforms perhaps haven't seen the traction arguably they should have done, right? Like, I don't know how many people who are using Kubernetes who truly like desperately need that level of complexity and pluggability. Well, like it's great that it's got it, and it's wonderful for Kubernetes that has happened because it's led to a very, very vibrant ecosystem with like a huge variety of users, and it's had to be very flexible. But I can't think of another project where that is kind of true, right? Like where people are.
My theory on this, and like being an old fart who doesn't know that much about Kubernetes, of course, it's like going to be entirely off base, and this is where you will laugh at me. But I feel like people who are using Kubernetes today, it's a little bit like they're booting the Linux kernel and working in a DramFS. In other words, the kernel is very useful to everybody. You know what I mean? In fact, everybody who uses the kernel today is doing that, but they're not grubbing around too close to it. You know what I mean? They're they're working quite some distance away from it. And on that basis, all of the kind of the complexity of the kernel, which most people probably don't need, is serving them without them having to sort of essentially just take it in the face. Now, exactly how, at least that's how it feels to me, right? Exactly how Kubernetes expresses a friendlier place for people to work, that remains to be seen, right? I feel like in the same way that, Unix took a long time to produce the desktop environments that developers like today, I suspect there's some distance to go in distributed systems. But that feels like the analogy to me. Like everyone's talking about the kernel and syscalls, and most Linux developers don't do that, right? Most Linux developers, it's fun to watch Brendan Gregg videos, but most Linux developers are kind of working on something specific miles away from that.
Lachlan, you want to react on it as working in Microsoft? Anything you want to add here?
Yeah, I think I would jump on the back of what everybody else said and just up level it. I think, yeah, we're living in the time where, everybody cares about how the distributed system that runs the distributed system that we're actually trying to run runs. But more, less and less that's going to become relevant as, a Linux user today may not know how the kernel works, or an interpreted language. Somebody who's writing in an interpreted languages may not know how that actually becomes bytecode, right? It's, we all remember in comp sci classes actually doing assembler and going back and looking at WASM. I was doing that the other day and I thought, wow, this is kind of a thing that I'd shoved to the back of my brain and going, I don't really need to know that anymore. It's not actually going to provide a lot of value for me to know that. There is somebody else that knows that, I guess, and it doesn't need to be me. So actually looking at where I can provide value, and I think that's what's going to happen is Kubernetes is going to become just an operating platform that everybody knows is out there. Few of us might know the innards of how it works, but for everybody else, it's what are those experiences we need to bubble up? What is the syscall that everybody builds the next platform? What is the syscall interface that we need to describe and that everybody needs to build on so that you don't necessarily care about the inner workings? That's just an exchange that's just a price of admission. That's your API surface area to get stuff done.
In the introductory kind of conversation that we had before the curtain lifted, Lachlan, you were talking about your interest and your current work in. It sounded to me like enabling the more kind of application developer oriented crowd. So folks who would be building an app for a business or an app for a purpose or a function or something like that to consume what Kubernetes offers without necessarily having to be in the thick of Kubernetes. I'm doing a terrible job of the introduction, but I'm curious if you want to talk a little bit about the sorts of patterns that you think are useful there, or ideas that you're exploring there that might be kind of nice for the next generation of developers who are going to use Kubernetes without really caring about it too much.
Yeah, absolutely. And I'll probably just peel it back a layer. I was talking about IDEs and making it really easy to onboard and scaffold out the YAML and really make a lightweight experience to build and deploy and scaffold out your first application. But something like Dapper, I think, is an interesting pattern. I'm not sure if you've looked at the distributed application runtime, but really it's about, hey, if you're a distributed systems engineer, do you really need to be in the business to know how to run a distributed state store, event queue, and do you need to know all that stuff, or can you just make that just an endpoint that you call and some other platform delivers that? So, how could we not make you have to code Kafka into all your applications and understand how Kafka event streams and all those bits and bobs work? How do we actually just give you an endpoint where you can say, hey, I want to subscribe to a stream. I'm going to use something like gRPC or REST to get that and not have to bake that all into your application. So providing modular building blocks that are stable across your runtime, and as a developer, you know how to hook into them. So I think that's just something that we've been trying to work on and building those different experiences rather than leaving, as an exercise to the developer to understand how distributed systems work in entirety. Seen other platforms out there. That's just one that I've worked on a lot that's really trying to, abstract all the complexities for running distributed systems and get you back focusing on writing your business logic.
Is Dapper? I did look at it some time ago, and my impression was that it was essentially enabling people to just use an API that assumed the existence of a bunch of capabilities, but without revealing to them the low-level details. Is that still the case?
Yeah, exactly. And making the low-level details pluggable. So however you want to get an event stream, a cloud provider can give you a great one. You might want to run one on cluster yourself, but making that more, opaque to the application developer.
And is that exposed in a sort of language specific way? So you would have a Python experience for Dapper and a Golang experience for Dapper and a JavaScript experience for Dapper. Is it?
Yeah, I mean, more or less, they basically just publish a set of REST endpoints or gRPC bindings that you can just pull into your application. So I guess it's a service mesh, a different take on a service mesh, rather than being more of an infrastructure take where we're looking at networks and plumbing. We're looking at services and applications. So I think that's just another way that we could describe and help cloud native developers not have to take on the burden of understanding all the distributed systems paradigms that are out there to know. The other good thing is just grappling with the copious amounts of data. So I think there's a lot of work that can be done going into making assumptions about, hey, if we see these signals coming from the platform, then we might be able to make some decisions about that much sooner. And, we see tools out there, and I think the tooling ecosystem around AI is interesting as well, just to be able to rationalize copious amounts of data coming from the distributed systems and start to bubble that up so that, I think one of the biggest values is doing that aggregation for you and giving you a very sharp look into what might be going on here. So I think that's, a really interesting tooling ecosystem that's about to develop as well.
Tim, do you want to react to it? I really also want you to, maybe comment on it, because we are speaking about IDE abstraction, helping the cloud developers. I think, Tim, we see that with the success of large language models such as ChatGPT or Google Bard, we see that there are more and more tools which are developed in order really to simplify the work of the developers. Any comment on it? Where do you believe Microsoft is going, for instance?
The focus on developer is super interesting. It's not the place where I've historically been focused, so I have a little bit of a less understanding there than Lachie for sure. Large language models in particular are super interesting in the last literally months, and everybody's got ideas around what we can do with them. What I've seen be really interesting, people are trying to get ChatGPT or Bard to write their Kubernetes for them. I actually see it more interesting the other way around. Tell me what this is doing. Seems to be more successful right now. Now I know these things are evolving very, very quickly, and probably by the time we talk again next year, the whole ecosystem will have changed there. But right now, the comprehension of it is interesting. I do hope that one day we can describe a distributed system in Kubernetes nouns, but in English, that we can have a system like Chat or Bard emit for us the primitives that we need, or even maybe a level above that, right? If Dapper is the thing that people are really using, then you emit some Dapper level configuration, and I don't even see the stuff at the bottom, in the same way that it can emit Go code today, and Go code is compiled into assembly, and assembly is run on the processor, and the processor, you got the kernel in between. Those users don't ever see it. I was thinking about, Mark, as you were talking about the kernel and how far people are from it, and as somebody who writes primarily Go code these days, the use of the syscall package is like a weird thing. Like nobody does that because it's an escape hatch for everything else, right? And I sort of feel like, in the limit, that's where Kubernetes should be. If you're aware of deployments and pods, you have sort of broken the glass already.
Good, thank you. Mark, it's just the time we will have wrap up. I wanted maybe for you to have the latest words, actually, because we are almost reaching the end of the panel.
I was just inspired to connect the dots between something John said right at the beginning of his comments and what Tim just said about syscalls and so on. And John talked about Juju rather remarkably in the case, but be careful, you love your baby, right? But the vision of Juju has always been to sort of provide this unified approach to wildly different applications in wildly different places. And John, I think what you're saying is it's kind of remarkable that the model, the language of describing applications and their scale and resources and integration and configuration and so on has been amazingly stable, even though the sorts of places that we talk about deploying those applications and even the sorts of applications themselves have changed quite widely, right? And that feels a little bit like, I think, coding in Go, right? Versus a world, and I think the current state of the art in a lot of operators, which peek and poke at all sorts of parts of Kubernetes memory, right? They're essentially empowered to be like kernel drivers, right? You just assume they're running at ring 0. And I think there's an unsafety to that. It may be the fashion, it may be the fad, it may be what people think they need right now, but there's something about that feels unsafe, right? Because you sort of imagine it's a bit like putting 2 binary drivers into a kernel. It's not just tainted, it's probably, well, I can't use the word, not safe for children. And I think that's very interesting, right? Like how do we find that boundary of things that people agree are sort of safe to let other people run and take care of on your Kubernetes cluster versus things that really you don't want, you don't just want to import and run. You certainly don't want to import and run multiple conflicting visions of them, right? It's an interesting way to think about what might be in scope for the Go runtime versus the syscall kind of approach, right, to operators.
If I can tie that right back to the beginning statement that I made about how difficult it is to write effective operators, one of the things I'm interested about Kubernetes evolving is making it safer to write operators that don't need all the permissions that they need today. Like you said, everything sort of runs at ring 0. If you want to do anything non-trivial in your operator, you have to assume a broad swath of permissions. And as a cluster person, that makes me nervous. It shouldn't be necessary, right? And so one of the things that's evolving in the API machinery group is a way to ratchet down those permissions down to a really small set so that your operator declares exactly which fields it's going to manipulate and in which ways. I'm super excited about that.
We take the view that the operator shouldn't actually talk to substrate directly at all. I mean, there's mechanisms for it to do that, but that's a little bit like importing the syscall package. Instead, the operator effectively is communicating with something that has a standardized model that may not one day be running on Kubernetes, right? And as a result, it has a much more limited view of what it can try to do, unless it's been written to be kind of like okay, I'm going to go peek and poke at the Kate's API directly. Please give me that. Please give me the magic ticket to do that. And I think in doing that, we got a lot closer, to the idea of things that would be safe to run in general on your cluster. It would be nice to have Kate's actually formally support that, right? And so to be able to hand out tickets that are themselves safe in some way.
John, you had a comment? You wanted to comment on it?
Yeah, again, something that kind of came up earlier on. Tim, you spoke about kind of API design, not taking those away, and Lachlan, you talked about kind of developer experience in Dapper and how it provides this like consistent way, and perhaps you don't need to know. And one of the challenges that I see pretty much daily with either our own kind of new people to Juju that we employ, like we hire people who come in and learn the Jujus, and there's community members and partners and other people using it, is this need to somehow express very, very complicated distributed systems concepts and kind of levers to pull, message queues, this kind of thing, in a way that you don't have to be a distributed systems expert, but also in a way that doesn't encourage people to hold them wrong, right? Like message delivery and guarantees are still a thing, no matter how pretty your API is, right? And so this kind of balance between like, how do I give developers something where they don't have to write, the equivalent of assembly, but also they don't blow their face off every time they try to do something? Because one classic example is people assuming, in our own operators, for example, that hook executions are kind of like a state machine, like they're somehow deterministic and they're going to run at a certain order, which fundamentally doesn't happen, right? Like it's distributed, like it happens at any time when you're not expecting it, and units go away and network problems happen. And that piece of API design and kind of software is so incredibly difficult to get right, it seems. And it feels like that's almost the thing that we're sort of all grappling with in our own area, right? As a kind of summary for some of the things we're all like struggling with at this point, I suppose.
All right, thank you very much. I think just caring about the time, it's time to close. So maybe some closing remarks before we finish. Mark, maybe?
Well, I just want to thank you very much to everybody who joined us. This is a very interesting conversation, sort of spanning the range from the more developer-centric kind of view of things. How do we make things easier for developers who just want to get on with it and not know 10 years of Kubernetes archaeology, to Tim's view of kind of the evolving state of the art in right at the guts and the heart of Kubernetes, and what's both challenging and sort of increasingly possible. Just thank you very much for joining us. It was lovely to see you again.
Thank you, guys, and have a good evening.
Likewise. Thanks very much.
Thank you.
Thanks a lot.
Thank you.